Hi guys, it's almost the end of the year and we're getting ready for our final exam. Part of your final exam is a 2-week lab that you conduct with a partner but is graded individually. It's worth 25% of your final exam grade, and your final exam grade is 1/9 of your total year grade. It's not averaged into the 4th marking period as it has been in other grades. It's called the Sludge test, and it's a combination of all the different kinds of labs that we've done this year. So you've seen all of the things you need to be able to do before, and the question is, how much of it do you remember, and how good are you at pulling up information from the past from your archive? So you want to go through your archive and start organizing your things so that you can do the things that you see listed on this page. There's 2 parts to the Sludge test. First, you need to separate the mixture that I give you. You don't know what's in it, but you will have to do all or most of these techniques. You'll have to use filtration, you'll have to fractionally distill your mixture, you'll have to fractionally crystallize it, you may or may not need magnetism depending which mixture you get, and you may or may not need flotation. There are other techniques that I taught you that are related to these, things like decanting, which is when you pour off the top layer of a liquid. That's related to flotation, and so on. Or, other types of separation techniques that I didn't bother to give a name, like picking something out that you can physically just pick up. All of that's okay. But these techniques you might want to review going back through your archive and making sure, do you know what equipment is needed? Do you know how long they take? Do you know what steps are necessary? Once you have your stuff separated, you need to identify it. These are the characteristic properties that we worked with for identifying things. You can check to see if your substance melts, but keep in mind our alcohol burners only get up to around 300 degrees Celsius, so if the melting point is above that, you're not going to see anything. And we don't have the proper equipment to determine exact melting point. We do know how to find boiling point, though, of a liquid, so you can do that. Density we're pretty good with, but keep in mind it's hard to find the density of a powder. Some of the substances that you will get will be powders, and the only way really to get the density of a powder is to use the displacement method, but for that to work you have to find a liquid that your powder does not dissolve in. Solubility can be really useful, and you can use it not only on solids, but you can also see what substances do or don't dissolve in a liquid that you've found. Specific heat capacity is good for metals. Keep in mind, it doesn't really work very well with nonmetals, and that's because metals are really good at conducting heat and nonmetals are not. So getting the specific heat of something that's not a metal can prove very challenging. Spectra, we've done a number of times. This is when you get a small sample and put it in the flame. Remember that to get the spectra, you need to get your substance to dissolve in a liquid first so that our alcohol burners will be capable of giving you a colored flame. And then there's reactivity with anything. It could be with oxygen, it could be with hydrochloric acid, it could be with copper sulfate, or it could be with something else. So you want to start going through your archive and figuring out, do I know how to do these separation techniques and use these different characteristic properties to identify substances? Then you want to stop and consider the possibilities. Anything could be in your sludge from this list. This is basically a list of chemicals that we've worked with this year. Some of them are compounds, some of them are elements. Some of them have common names that I changed to the scientific name just to make it a little more challenging for you to figure out what they are. However, not all of these things can I put together in a mixture, right? So you're going to get a mixture that contains probably 6 different items. Sometimes I do 5, sometimes I do 6. Different groups are going to get different mixtures just to keep you honest. Otherwise, I find that students have a tendency to do sort of a collective cheating, even if they don't mean to. They just share a lot of information among groups, and that makes it more difficult for me to grade you. So each individual, there's I think 12 different varieties of sludge that I have, so each person in a class usually has their own unique sludge that has a different combination of items in it. So what do you do with this list? Well, one thing you could start doing, because the sludge isn't coming up for another week, is you could start researching the things on this list. And what you want to do is figure out what information is going to be most useful to me. What do I want to know about these different chemicals that'll help me determine how to separate them and what they are once I have them separated? So you need to figure that out. And then the next question is, where can I find this information that I'm looking for? I've suggested to you that Google is a good place. Usually if you type in the name of the chemical that you're interested in into Google, you'll find a couple of different resources. Believe it or not, usually Wikipedia is pretty good on its chemical information sheets. I don't tend to find errors there. Usually when I think there's an error on Wikipedia, it turns out to be my error and not theirs. So even though you may not trust Wikipedia for more complex things, some basic factual information they tend to get right. But you don't have to use Wikipedia. You can use any chemical analysis sheet that you can find online. But what you want to do is not overload yourself with tons of information. Think about what information is going to be useful to you. And then before you do that, you should probably do this next thing. A good way to organize your thinking to prepare for a separation is to create a flowchart. And I'm going to show you how to do that using this mixture that we've done before of sand, salt, sesame seeds, iron filings, and potassium nitrate. So when you know what the components of a mixture are, you can start a flowchart by just putting all the things that you know you have into a circle at the top of your page, and then creating a line that has labeled next to it the procedure you want to do first. So what would be the most logical thing to do first? Well, in this circumstance, the best thing to do is to get that the iron out by magnetism. So I've put the word magnetism up there next to my arrow, and I'm going to turn the arrow into a two-headed arrow, because through magnetism, I'm going to separate this mixture into two components, iron and everything else. So you can see we have the iron over here, so that's done. So we usually circle done ones. And then on the left-hand side, we have the sesame seeds, the sand, the salt, and the potassium nitrate. And I've switched over to the formula to save space. So what's the next step in this procedure? Well, the best thing to do now is to add a little bit of water and get those sesame seeds to float. So when I do that, I'm going to get two arrows again. One for the sesame seeds, and then the rest of the stuff will stay put. And now the next procedure would be to filter out that sand. So let's get a different color arrow here. Oh, I should circle my sesame seeds. And now I want to filter out the sand. And that gets the sand out, leaving the salt and the KNO3 clumped together, and we'll have to do fractional crystallization to get that apart. And after we fractionally crystallize it, we'll have our KNO3 and our salt in two separate piles. So that's a flowchart, and that's what I want you to create. So every flowchart is going to look the same. It's going to have a collection of things that are mixed together at the top, a down arrow that has a type of technique written on the side of it, and then two branching arrows that show how that technique separates something or several somethings out from your mixture. And then you repeat the process again and again. So each new arrow down shows a new technique being used, and you want to try and get those to all fit on one page. Now, it's much easier to do this because we know what the substances are in this mixture. But for your sludge test, you don't know what substances you have. So instead of calling your beginning substances sand, salt, sesame seeds, iron, and potassium nitrate, you're going to have different things, which could be, anything from the list that I showed you before. So here are some ideas of how you can generically name the things in your starting bubble. You could put all these things in your starting bubble if you want to, and you may find that you want to add others, or maybe you want to use slightly different terms or something. It's a lot to put in your starting bubble, I'll grant you that. So maybe there are other ways to do it besides this, but basically you're looking to separate soluble from insoluble substances. You're looking to separate magnetic from not magnetic, high boiling point things from low boiling point things. Things that are soluble at high temperatures from things that are less soluble at high temperatures, things that are low density versus high density. You want to think about the fact that you're going to have a mixture of solids and liquids. So you'll have at least 2 liquids, and you could have up to 4. And the same thing with the solids. You'll have at least 2 solids, and you can have up to 4. So you have a total of 6 different things, and some of those things are solids and some of them are liquids. So you have to figure out how to create a flow chart that's based on a generic mixture that you don't know the specifics of. And then you can apply separation techniques and say, okay, instead of, I'm going to do flotation and my sesame seeds are going to float, I'm going to do flotation and my low density items are going to float, and I'll scoop them off. So you have to really think about this to create a flow chart that makes sense. I would start, if you're confused, I would start by going back to the flowchart I created on the previous slide and substituting in the generic words for each substance. So instead of saying sand, what would sand be? Sand would be a insoluble solid dissolved in water. This thing here. And so on. So substitute those names into that original flowchart and you'll get an idea of what you need to do for this one. You want to bring that flowchart to class and have me look it over so that I can give you feedback on whether or not you're barking up the right tree or not, because you don't want to be on the wrong tree when you actually start this project. And then there'll be other tutorials to help you with some other things like how to use your characteristic property tests and how to make good decisions there. But getting the stuff separated is your first big challenge. After you're done separating it, you can spend time identifying. I'll see you guys in class.